how does the Earth's magnetic field protect itself from solar flares? The magnetic field doesn't protect itself from solar flares, it protects the Earth from the solar wind. What is the solar wind? Oh, where you have it? There you have it. Wow, I did not know you could do that. Can I see Mars? You can even see Mars. Venus? You can even see Venus from here. Anyway, let's come back to that. I apologize. I like toys. Give me a toy, I'll play with it. Okay, so here's the deal. The Earth has a magnetic field. Okay, what is the origin of the magnetic field? The origin of the magnetic field is the interior of the Earth, this liquid metal below the magma layer, which is in motion, and you have charged particles in it, and charged particles in motion give rise to uh, a magnetic field, which all of which, well, it originates in special relativity. So we have a magnetic field, a reasonably powerful magnetic field. The lines of force, they kind of originate at the poles, roughly around the poles, North Pole, South Pole. Now you have something called the solar wind. The solar wind is this stream of charged particles, protons, electrons, etc., that flow out of the sun. Tremendous amount of solar wind is flowing out of the sun at any given point in time. It's plasma. So, and then you also have cosmic rays and much more. Okay, that comes from all over the galaxy. So, but we're talking about solar wind here, not solar flares, solar wind. And solar flares also give off large quantities of solar wind, charged particles that can mess up the electronics on the planet and inundate the surface of the planet with all kinds of terrifying particles, which can give you cancer, destroy your DNA, mutate your DNA, cause damage of all kinds, and all that. So, what happens is that when you have a magnetic field, charged particles, they move in curved lines in magnetic fields. Okay. Now, what that does is that we have these magnetic lines of force coming out of the polar region of the Earth, and these magnetic lines of force, they trap the charged particles coming from the sun and concentrate them in some parts of the Earth, where they enter the atmosphere and glow, and that's what causes the auroras. And most of these charged particles, they're trapped in the magnetic field, and they never really reach the atmosphere and the surface of the Earth. So essentially, that's kind of what happens. And the magnetic field of the Earth is what essentially ensures that we have this kind of life on the planet. And that's why we still have oceans on the planet. If you look at Mars, it's very clear, looking at the surface of the planet Mars, that there were once oceans on Mars, oceans of water. There were rivers on Mars. You can see rivers and canyons and all the shapes left behind by that. But where's the water? All the surface water has disappeared, except for wherever you have some ice. So why did all the water disappear? It's because Mars lost its magnetic field. So the solar wind stripped away the atmosphere until we have a very thin atmosphere left on Mars. And the solar wind, all those charged particles, they destroyed the water also. They ionized the water in the process of very slow electrolysis. So water was ionized, dissociated into hydrogen and oxygen, and all the water disappeared from the surface of the planet. So that's what would happen if we did not have a magnetic field on the planet. The magnetic field traps the solar wind and prevents it from destroying the atmosphere and water.